All right, let's pick back up with number 3 here. And we're looking for the measure of angle 2 and the measure of angle ABC. Okay, given that the measure of angle 1 is x degrees, find the measure of angle 2 and the measure of ABC in terms of x or y if Q is parallel to R is parallel to S. So that basically says all 3 lines are parallel to each other. Also, if angle 3 is congruent to angle 4 and we're given an expression for the measure of 4. Okay, so let's label some things here. I'm going to switch colors. So angle 1 we're going to call x. So I'm just going to put an x here by angle 1. Angle 2 we need, ABC we need. I'm going to come back to what it means by in terms of. Let's mark 3 and 4 congruent with an angle arc. So I'm going to put an arc on 3 and an arc on 4. Which that makes sense, right? Because these are alternate interior angles. Okay. Angle 4 is 180 minus x. So I'm going to slide that in here. 180 minus x. Okay, so what it means in terms of x or y, I'm probably going to have an x and or a y in my answer. Okay, so that's what it means in terms of something. Okay, so what I think I'm going to do here, if this is 180 minus x, I'm going to go ahead and call 3 180 minus x. Okay. Okay, I have a y over here. I didn't notice that. I have a y degrees. I don't have anything on 2. All right, so the measure of angle 2 is what I want to find out. Okay, so I really can't relate 2 to 1. Okay, because, and you can tell if these are all parallel, these should be the same size. And so I'm missing part of a corresponding. Same thing with 4 and 2 don't have a direct connection. So let's come on over here. Take a look at y and angle 2. So these are, and sometimes it helps to turn your paper this way possibly. If these lines are parallel, and this is my transversal, angle y here, or y degrees, and angle 2 have a relationship. Those are consecutive interior, okay, they are along the same transversal in between the lines. And since the lines are parallel, they're supplementary. So I don't know the value of y, but I know that 2 has to combine with y to equal 180. So I can write 2 in terms of 180 minus y. 180 minus y. Because if you think about it, if angle y was 100, in my head I'd say 180 minus 100, okay, angle 2 is 80. So I don't know what the answer for y is, so let's leave it in terms of y. All right, angle 2. Really all I can do, remember, you're going to have x or y in your answer. So if I look at this angle together, if I kind of think of it more like this, angle 2. If I need to get, actually, let me pause here. I'm getting ahead of myself. I just have the expression for angle 2. So the measure of angle 2 is 180 minus y. Now, sometimes you'll see it like this, parentheses degrees. It's fine if you just write 180 minus y, but basically it's saying whatever you come up with is in terms of degrees. Okay, ABC. I was getting ahead to ABC down here. So A down to B over to C. So this is angle BA. So what this is asking is, what is an expression for this big angle? Well, we could use the angle addition postulate. If I were to add 2 to 3, that would give me all of ABC. So again, it's going to have a variable or 2 in it. So let's add these together. So I can take 180 minus x plus 180 minus y. And then let's just combine as much as we can. We can do 180 plus 180, which is 360. And that leaves me with 360 minus x minus y. And that's really about all I can do. So the measure of ABC, if I want to be real precise here, is 360 minus x minus y degrees. Okay? So when you see something in terms of, x or in terms of y, that means you're going to have x or y or both in your solution. Okay. All right, let's move on to this last page here. All right, number 3, find x and y if L is parallel to M. Okay, so L is parallel to M. Okay, I see some squareds. I see both variables, x and y. So let's look for some connections here. All right, 3y and 5x squared, these are corresponding. They are equal. I'm going to pause on that one because I know I can't solve it because they both have the same variable. I have alternate interior angles here. So another way I could set 3y equal to this expression. But notice your vertical angles. These are equal, and they both have x's in them. So I'm going to probably start here. I don't have to start there, but I think that's what I'm going to do. So I'm going to set up my vertical angles. So I've got 5x squared equals 11x squared minus x minus 2. And so what I can do here is try to start solving this one. So probably going to have to factor it, or if you want to use quadratic formula, you can. So in order to do either, I need 0 on one side and then everything else on the other. So when I do this, I want to keep x squared positive. So that means I'm going to move or take away 5x squared from both sides. So that leaves me with a 0 over here. 11 minus 5 is 6. So there's 6x squared minus x minus 2. Okay, I'm going to factor. Now I'm going to switch to pencil because I'm going to do the guess and check method. If you like to do that split the middle method or make that kind of diamond or X over to the side, you can. All right, because I'm probably going to have to do some erasing. So I'll do all my signs in a minute. So my factors of 2 just has to be 1 times 2. But my factors of 6 could be 1 and 6 or 2 and 3. So I like to start at the bottom of my list because 95% of the time it works out that I'm dealing with 2 and 3, not 1 and 6. So I'm going to start here. 2x, 3x. And then I'm just going to throw in 1 and 2. And maybe I'll get lucky and it'll work. So remember, I know that the 2 times 2x and 3x is already 6x. And I can make 1 and 2 multiply up to a negative 2. I'm trying to get this negative 1 right here. So I'm going to check these 2 multiplied together plus these 2 multiplied together, or plus or minus, to see if I can get it to say negative 1. So this is going to be a 3x. 2x times 2 is 4x. Okay, I can get that to say negative 1. So if I make the 4 negative and the 3 positive, these 2 add up to negative 1. So that means I'm going to come back up here. This should be plus, and this should be minus. Okay, and so let me just show you here what I have, because if you haven't, we don't do a lot of factoring. Let me just multiply that back out. So I would have, this would be 6x squared minus 4x plus 3x minus 2. So can you see how I get negative 1? I'm sorry, that's a little bit light on the video. See how I get a negative 1 and I still have a 6x squared and I still have a negative 2. Okay, so however you want to factor, if you want to guess and check, if you want to, split the middle, however you want to do that would be fine. Okay, so then from here I need to solve for x. So I'm going to write 2 equations. 2x plus 1 equals 0. 3x minus 2 equals 0, and let's solve them out. So minus 1 will give me 2x equals negative 1. Divide by 2, negative 1/2 or negative 0.5. So plus 2 would give me 3x equals 2. Divide by 3, x equals 2/3. Okay, so I've got 2 answers for x. Okay, and it's okay because I'm dealing here with, actually, I guess I should probably check here real quick. Let's make sure that this negative will work. Now, if I think ahead, when I square a negative, I always get a positive. So this is going to end up being a positive. Same thing here. When I square this negative, I'm going to get a positive number. And then when I do minus a negative, that'll be positive. So they both are going to work here for my answer. So I'm actually going to have 2 sets of answers, okay? And so let me kind of continue on. Let's start with, or stick with, the 1/2. So if x is 1/2, what's the value of y going to be? So what I could do let's see, I know that 3y, this angle here, and 11x squared minus x minus 2 are equal to each other. So I'm going to plug negative x squared in right here, and let's see what I get. So I'm going to substitute, and I'm going to say 11, and I'll go ahead and switch it to negative 0.5 times negative 0.5 squared minus negative 0.5 minus 2. Okay, and you can just put that all in here. So I can say 11 times negative 0.5 squared, because your calculator can do order of operations, minus negative 0.5 minus 2. So negative 4.25. Okay, so that means that this angle is negative 4.25. And so this angle would be negative 4.25. So hold on a second. Something seems off. Okay, I know what I did wrong. I can't have a negative angle. So here's the drawback to doing the calculator. See how I didn't put parentheses around this? So let me back up a little. Let me separate it back out. So let's do negative 0.5 squared. So positive 0.25. So then I'm going to multiply by 11. So I get 2.75. So I could say 2.75 minus negative 0.5 minus 2. So I could kind of step through a little bit. Okay, that makes more sense. This should be a positive angle measure. So that means that this angle is also that 1.25. So I'll put 1.25 here. So then I could say, well, 3y has to equal 1.25, and then now I can solve that for y. So let's just divide that by 3. Okay, so I probably want to turn that back into a fraction. I mean, I could put the repeating bar above it, but let's turn that back into a fraction. So second fraction decimal, so 5/12. So y is equal to 5/12. Okay, so one of my answers is if x equals negative 1/2, y equals 5/12. Okay, that's one answer. So now I got to do the same thing if x is 2/3. All right, so let's plug in. Let's do a different one. Let's take this angle right here. This probably would have been an easier one to do. 3y is equal to 5x squared. Okay, so let's figure out what that angle is. So if I do 5 times 2/3 squared, 2 2/9, I always like to turn it back to an improper fraction, 20/9. So that means this angle right here is 20/9, and it's equal to 3y. Okay, so we could divide both sides by 3 if we wanted, or we could multiply by 1/3. I'll just do divided by 3. 20, 27. So I'm getting some bizarre answers here. Well, not really bizarre. They're just usually we're dealing with like whole numbers and things like that. But we can still work with ones like this. So if I have 2/3 for x, then I get y equaling 20/27. Okay. So this isn't quite a complicated problem for parallel lines. All right. So what I want you to kind of step back through. Step 1, solve for x. And it's okay that I got 2 x's because I still got positive angles. Then I had to separately plug them in. So there's actually 2 sets of answers that work for this problem. Okay, I want you to try number 3. And so pause the video and then come on back and I will work through 3 with you. Okay, let's see. We've got several sets of parallel lines. See the markings here. I've got 2 different transversals. So I've got x and y in an expression, same in the other. So let's write some equations down. All right, sometimes I like to turn it this way. All right, I have an angle right here. I'm going to kind of shade it in pencil. This angle right here, follow your transversal down. Let's see, 55. So these 2, when I color them in a little, they are alternate interior. You can block this line out here. So that means these 2 expressions are equal. Okay, so I'm going to write that down. So I've got 5x plus 4y is equal to 55. Okay, so I'm going to let that sit there, and let's look for another set of angles. Okay, this angle right here, I'm going to shade it in, and then if I trace this down, 60 is right here. So these two are in the generally the same area, kind of like, actually if I look at it this way, the lower left and the lower left. So these are corresponding, and the corresponding angles postulate says they are congruent. So there's another set of angles, or another equation I guess I can write down. 60. Okay, so I'm going to solve this with a system of equations. There's a number of ways to do this. You're trying to get the x's to add up to 0 or the y's. Now, one way to do this, you could say, well, can't I just subtract 5x from the top? And you can, but you also have to subtract 5y and subtract 60. So what I like to do is I like to say, all right, I'm going to multiply through by a -1. So I'm going to maybe move over to the side here. So I'm not going to mess with the top equation. But what I am going to do is multiply through by a -1, which makes all of them change sign. So -5x minus 5y equals -60. Now, when I go to add, then I don't have to worry about remembering to subtract all the other ones if I just want to subtract at the beginning. So these guys are gone. 4 minus 5 is -1y. 55 minus 60 is -5. And then divide by -1. So I get 5 for y. Okay, now we can plug it in anywhere. I can plug it in here. I can plug it in here. I'll just go to the top one. So I'm going to have 5x plus 4 times 5 equals 55. So 5x plus 20 equals 55. Take away 20. 4, 3, 35. And then divide by 5 is 7. So I've got x equals 7 and y equals 5. So that was a little bit easier to solve than the one above it. But these two problems kind of represent some of the algebra we're going to keep working on. So system of equations, and then this is a rather complicated factoring problem. So okay, well, if you have any questions, please feel free to let me know.